zone. If y'all would, Miss Bonds, turn that camera that way just a little bit. Come on, just a little bit more. That's it right there. Perfect. Perfect. All right, so today we're going to talk about, y'all pay attention. All right. Today we're going to talk about organic nomenclature. Tomorrow we're going to take a quiz on ionic nomenclature, which we learned last week. Also tomorrow after the quiz, which is only 5 questions, by the way, so it should take about 5 or 10 minutes at the most. 5 or 10. All right, so we'll knock that out. Then we'll talk about acid nomenclature. If we need to do a little bit of that on Wednesday, we will. It's looking like we'll have a very rare opportunity of reviewing a little bit the day before the test. Test is Thursday, and I will not be here Friday. The test is 50 questions, all mixed up. I give you names, you give me points. Okay, it's just random selection of names. It could be ionic, it could be polyatomics, it could be one of the 7 diatomics, it could be binary covalent, organic compound, or an acid. Just random order. So the first thing you have to do, for example, when you get to number 1, is you have to figure out what is this I'm looking at. Is it ionic? Is it binary covalent, organic, acid, polyatomic ion, or one of those 7 diatomics? That's the first question that you ask yourself on every question, because it will not show you that directly. Okay? So you figure that out, and then you apply the correct system for naming, right? And you go to number 2, do the same thing. All the way down to this. Okay? You'll have a periodic table. So have that. We're going to identify an ionic compound because it's going to have a metal or ammonium, right? So the first word in the name is a metal or ammonium. That's ionic. You're going to apply that crisscross method. Okay? If the first word in the name is a non-metal, okay, then we're going to have to think about it a second, because it could be a binary covalent compound. Okay? It could be a polyatomic ion. It could be organic, or it could be an acid. So we'll go from there. Acids are easy to identify them because actually it's an acid. Okay, so Friday, I think, we learned this binary covalent nomenclature, which has to do with this list of prefixes right here. Right? It's all based on the prefixes. Monodiene, tritetra, that's 1, 2, 3, 4. And pentahexaheptanoxy, and deca, 5 through 10. Okay. Today, for organic chemistry, we have a different set of prefixes, almost the same, but it's different. The first 4 are different. Okay. So the organic prefixes are F, F, pro, bute. That's 1, 2, 3, 4. And then pentahexaheptanoxy, after that was 6, 5 through 10, the same as here. Okay. I don't know why they're different. The aggravation is that they're different, obviously, but just whatever you do, please don't blame the teacher. I don't make this up. This is not the Cato method for naming chemical compounds, okay? This is all devised by a committee of nerds in Europe or North Carolina or someplace, okay? And I didn't have anything to do with it, okay? But the purpose in it is that chemists all over the world can communicate, okay? So having an international union of chemists means that we standardize conventional things across the world. So no matter what your language is or whatever, if you're writing a chemical paper, doing some kind of chemical research, then everybody in the world can read it, or at least read the chemistry part of it. They have to have the grammatical stuff translated, but the chemistry part is universal. Okay. Before we get too deep into this, we have to skip ahead a unit just a minute. Yep. So, skipping ahead of ourselves here just for a little bit, we need to sort of briefly and very simply define a single, double, and triple bond. We're going to these things much more detail as fall break, but we just need to kind of know what they are for a second. Right? Because the organic nomenclature system depends upon whether the single, double, or triple bonds are compound. So what is a single covalent bond? It's a sharing of two electrons, a pair of electrons, a single bond. And if two atoms are sharing 4 electrons, which is 2 pair, that's a double bond. And if they're sharing 6 electrons, which is 3 pair, that's a triple bond. Okay? Am I good with that? That's much more to know about that, but not right now. Okay? You just need to know what they are. There's no such thing as a quadruple bond. Just triples. Single, double, triple. So we need to kind of just know what that is, because the way we're going to name these things and write their formulas is dependent upon whether they have single, double, or triple bonds. So if you click that link right there on the slide, this is slide number 114. It will take you to this document right here, which will be your best friend in learning this. If you don't have a best friend, if you're looking for a best friend, you just found one. Yeah. All right, so here we go. Now, we're going to keep this very simple. Organic chemistry gets extremely complicated, all right? If you take organic chemistry in college, it will be the most difficult class you ever take, most likely. Okay? All right? If you're headed to the medical field, then you're going to take this, okay? And you're going to make an A in it, or you're not going to be headed very far into the medical field. Okay? At least not MD. If you would like to have MD after your name, you get to make an A in this instance. Medical doctor. Oh, you just want PhD, you can get by with it. If you want MD, PhD is Dr. Possible. So, here we go. Again, this is very simple compared to what all this really can get into. So let's start with the simplest of the simple. What are called straight chain alkanes. We're going to have 3 words here that we're going to learn today: alkane, alkene, and alkyne. And that's 1 letter difference in each one of them, okay? Which makes it tricky and aggravating, and means you're going to have to be careful, make sure you're reading what you think you're reading. Okay? Very similar to phosphide, phosphite, and phosphate. Now, those are 3 very different things with very similar spellings. Okay? So an alkane is a compound that contains only carbon and hydrogen. Let's go back and define organic. That's good. Let's define organic compound real fast. It contains carbon and hydrogen, and maybe something else, but at least carbon and hydrogen. Okay? Carbon and hydrogen and maybe something else. The maybes, most predominant, something else would be oxygen. We'll see that in a little bit. Followed by nitrogen, then maybe sulfur or phosphorus or halogen or something else. Okay? But at a minimum, we got to have carbon and hydrogen. Fine. So the alkanes, alkenes, and alkynes contain only carbon and hydrogen. An alkane is going to be all single bonds. An alkene is going to have a double bond. What do you think an alkyne is going to have?
Well,
Triple. So alkanes, A and E, everything's single bond. An alkene with an E, so we change an A to an E, and that means there's at least 1 double bond in the compound somewhere. In our case right now, it's only 1 double bond. And we'll see here in a minute, an alkyne with a Y has a triple bond. So the different names are telling you the type of bonding that's in the compound. So the prefix, though, each name is consisting of a prefix and a suffix. We're familiar with those terms, right? Prefix and suffix from English class. All right. So the prefix tells you how many carbons, and the suffix tells you how they're bonded. Okay. once you determine the carbon number and how they're bonded, there's a formula for the number of hydrogens. So you do not have to memorize all of this that's on here. Usually when people first look at that, they go, oh my gosh, I gotta memorize all these things. Nope. You gotta memorize like 3 or 4 things. Okay? You gotta memorize these organic prefixes. We gotta know those. And then we gotta memorize some formulas. Okay? So for example, find my laser pointer. All right, so starting right off at the top here, methane. Okay? So meth means 1 carbon, and A and E means they're all single bonded, which means we're going to use this formula right here to come up with the formula of the compound. There's 1 carbon because it's meth. The hydrogens are going to be 2 times the carbons plus 2. So 1 times 2 is what? 2 plus 2 more is 4. 1 times 2 is 2 plus 2 more is 4.
Right.
So methane is CH4. 1 carbon, 4 hydrogens.
He said it says it has A and B.
Yep, which means we're going to do a times 2 plus 2 formula to get the hydrogens. The prefix tells us the carbons. So propane, for example, pro means 3. So that means 3 carbons. And then we're going to multiply by 2 and add 2 to get the hydrogen. So 3 times 2 is 6, and plus 2 more is 8. So propane is C3H8.
Oh, okay.
Okay. Let's pick another one here. Hexane, real common component of gasoline. Hexane, 6 carbons. Hex means 6. A means everybody's single bonded. So 6 carbons times 2 plus 2 is 14. I have 14 hydrogens. C6H14. Everybody can see how that works?
Yes.
So you got to memorize your prefixes and know that A and E needs to use that formula right there. Okay, but if it ends in E and E, so the suffix is E instead of ain, it's going to be this formula. So that everything's the same, this formula is a little different. Okay, so and you can ignore this little 1 in front of the name. That technically is just telling the location of the double bond. We don't need to know that right now. Okay, so we'll ignore that. And I'll probably just leave that part off with this. But for example, if you had butene, that means 4 carbons and there's a double bond. So 4 carbons and we need this formula. The formula for alkenes is just to multiply times 2 to get the hydrogens. Not 2 plus 2, but just times 2. So butene is C4H8. Hexene, C6H12. Octene, C8H16. So on and so forth. Notice there is not a methane that doesn't exist. Okay, everybody good with that one? So single bond times 2 plus 2 for the hydrogens. Double bond times 2 to get the hydrogens. If it's triple bonded, we're going to times 2 and subtract 2. So for example, propine. Again, just 1 letter difference, so we got to read carefully. Propine has 3 carbons, and to get the number of hydrogens, we're going to multiply by 2 and subtract 2. Well, 3 times 2 is 3 times 2 is 6.
Oh, my fault.
Minus 2 from that, you would have. Okay, let's try again.
Oh, my bad.
Propine means 3 carbons, right? And then we need this formula.
Right.
So 3 times 2 is
6.
minus 2 is 4. So propine is C3H4. Pentine, C5H8. 5 times 2 is 10, minus 2 is 8. Right?
Got you.
See how it works? Okay, so we got to memorize prefixes, and we got to memorize a single bond formula, double bond formula, and triple bond formula. Ains, the enes, and the ines. Prefix tells you number of carbons. Suffix tells you the bonding situation, which tells you how to calculate the hydrogens. Good with that? Okay. Now, if we add oxygen to it, we get real complicated. Going to be that way. Okay, we're going to keep this real simple right now. We'll come back to these other things later. But if you add oxygen to it, you get all kinds of different compounds. You get things called carboxylic acids, you get aldehydes, ethers, esters, all kinds of stuff. Okay, and we're not going to deal with all those right now. We are going to deal though with the most common of oxygen-containing organic compounds, and that's alcohols. We run into alcohol every day. Okay, two different alcohols. What?
The alcohol that people drink, and the alcohol that.
That people drink. Yeah, two different alcohols, but both on the list here. Okay. So alcohols, all right. There's two very common ones. There's millions of alcohols, but there's two very common ones. One is what we call rubbing alcohol, which is this isopropanol on the list right here. Okay. You go to the store, it may say isopropanol on the bottle. It probably says rubbing alcohol on the bottle. Okay. That's sold in the pharmacy section for like $1 a bottle. Okay. It's cheap, but it's not taxed because you can't get drunk off of it. Okay. Some people think you can. All you're really getting is sick. It will make you very sick if you drink it. So will ethanol make you very sick, but it's a different kind of sick. Okay. So I always say that because there's always some dumb teenager somewhere who thinks that getting around the system. They won't let them in the liquor store, so they go to the Walmart pharmacy and buy a $1 bottle of rubbing alcohol and think they're going to have parties every night. All you're going to have is a bunch of people throwing up in the floor, okay, or maybe dead in the hospital. Okay, that's all you're going to get out of it. You know?
Exactly. Both of them are throwing up. So.
It's just a poison.
Well, the other one, yeah,
Yes, it's a poison. Well, because it's poison, not. So that's an excellent question. So the question back here was, if it's poisonous, how can you get away with putting it on a wound or something that's disinfectant? Because if it works as a disinfectant, the simple answer is that it's literally killing the bacteria, the viruses, right? But it kill you too. You're a lot bigger than a bacteria or virus, so it takes a little more, right? But if you turn the bottle up and drink it, it'll disinfect you completely, right? Okay, because it's going to start destroying your internal cells, and I mean, it's just like it's ripping the bacteria up.
So that's the cure to cancer.
No, well, I mean, yeah, but you're not going to survive the cure or something. That wouldn't cure cancer. So anyway, that's isopropanol. The other very common alcohol is ethanol. And that's drinking alcohol, but it also has a daily use in our modern society, and it's 10% of gasoline that we buy. So it's mixed into gasoline because it does make a good fuel, fairly clean fuel. It's kind of controversial, but one thing that's controversial about having ethanol in gasoline is the real reason that we have ethanol in gasoline is not environmental or energy security or anything else. If you know anything about politics, presidential politics, the first primary every year, actually it's a caucus, is in the state of Iowa. So if you want to run for president, it's a series of electoral victories that you have to accumulate through the primary system to get your party's nomination, right, to go run an actual election. Okay? Well, everybody wants to start off with a win. So Iowa is always the first one. And Iowa is 100% corn-based economy. Okay? It's big money. A lot of really wealthy farmers. But the whole economic system in Iowa is based off that. If corn's not selling well, then Iowa's in trouble. Because nobody has any money. Nobody's going out to eat. Nobody's going to movies. Nobody's buying a car. Nobody's doing anything in the state of Iowa with corn prices on up. So, all the presidential candidates of both parties go to the state of Iowa and promise them the moon, which means they're saying we're going to make sure that your prices are always high. And one way they do that is by requiring that 10% of gasoline contain ethanol, which is made from corn. So there is a vast majority of the corn that is made, that is produced, grown in those states, especially Iowa, that goes into fuel, not to food. Interesting. And they make that ethanol the same way you make moonshine or whiskey or anything else. Just instead of you ferment the corn. So give a little chemistry lesson. The corn has sugars in it. Okay, so you get high fructose corn syrup and things like that. It's got all this sugar in it. So you ferment it, which turns the sugars into alcohol, and you just through a distillation process, you separate out the alcohol. And then at that point, you have two options. You can make Jim Beam or Jack Daniels or some other drink, or you can pour the gas tank. You gotta get the water out of it before you pour the gas tank, which is a whole other trick. It requires poison.
So, like, in movies and TV shows, you'll always see, like, if somebody's sharing in the wilderness and they get hurt, they'll pour, like, liquor on the wound. Like, but for us, that's not isopropyl alcohol. How does that work?
It still kills
It's
the germ.
strong.
It's still a germ, but it's stronger. Yeah, it's still a germ killer. Those alcohol compounds, they're similar to each other in the fact that they're both going to kill bacteria or virus, especially bacteria. So yeah, you can use it as a disinfectant or a fire starter.
If ethanol is stronger, why does it not kill it?
It will if you drink enough of it. You drop it, drink it too fast. So ethanol has an interesting, biochemistry here. Okay. Interesting thing about ethanol is that at low levels, it seems to be, as anybody can tell, not harmful, and maybe even health beneficial at low levels. Okay, so and that's been known for ancient times. There's biblical passages that recommend drinking a glass of wine and stuff like that. Okay, so from way back, people realized that there was something good about it. They didn't understand the chemistry of it. One of the things in ancient times that they were doing and didn't realize it was that having a little alcohol in what they drank was killing the bacteria that was in the water because they didn't have water purification. And if you lived in a town, let's just go to Middle East 2,000 years ago, right? If you lived in town, if you lived in Jerusalem, okay, and you drank the water, you probably wouldn't live very long, okay? Because it's contaminated, because sewage and everything, everybody just dumped it all wherever. So you probably wouldn't live very long. But if you drank wine, then for some reason you didn't die, okay? Because what they didn't know was the alcohol in the wine was killing the germs, okay? So if you lived in ancient East, China, places like that, they all drank, and still do, hot tea. What they didn't know was that they realized through trial and error that people that boiled tea and drank it did die. And people that went and drank water out of the creek, they died. Okay? And what they didn't realize was that boiling the water was killing germs, same as the alcohol. So those two different tastes in drink emerged from thousands of years of trial and error, and realizing that you drink fermented drinks or you drink boiled drinks, you live longer. And your stomach doesn't hurt all the time. Okay? But ethanol is an interesting chemical in that it's pretty good for you if you don't drink but a little bit. But there's a line, okay? And when you cross a line, your body kicks into a different mode. Several different metabolic things start to happen. And it causes you to be in a mentally altered state. And it also causes your internal organs to operate differently. So if you drink more than one, what we classify, and there's a reason that a drink a day, there's a reason that beer isn't sold standard in a 12-ounce bottle. And then a wine glass is a certain size, and a shot glass for whiskey is a certain size. A beer and a glass of wine and a shot of whiskey have the same amount of alcohol in them. And that's considered one alcoholic beverage. And that's that way for a reason, is that studies show that one alcoholic beverage per day is not going to have negative effects, so it appears, and it might have positive effects. Okay?
Yeah.
One a day.
What type of drink?
That's if you're over a certain age. That's
So I took me a shot of vodka, you know.
well, if you were my age,
I keep it on.
okay, so if you were my age and you took one shot of vodka a day, first off, it's not going to hurt you. And it might, like for me, it's not going to hurt me, and it might actually improve my health. Okay, at your age, because you're in a different developmental stage than I am. Okay, a shot of vodka could be detrimental. Just one shot of vodka is not going to be good for you. So there's more reasons. So there's multiple reasons for why there's a drinking age. Okay, number one reason there's a drinking age is that people under a certain age are not wise enough to know how to control how much they drink.
I think I'm a little
Statistics say you're not. Okay,
Well, what if
So-
I'm like the crazy 1%?
you may be. And that's
Like,
fine.
how is
Too
this
bad.
just
You're right. Up to that.
No,
The second thing is,
Europe's drinking age is like 14.
yes, because their culture looks at drinking so much different. Americans drink. I get on the soapbox here. Americans' drinking culture is so stupid. Okay, here's what I mean by that. I have adult friends. Like I'm not drinking every blue moon. I'll have a beer. If somebody buys me one, I'll drink it. Like I'm not rude, you know. Like if I'm at the restaurant after a game with my official buddies or something, they say here, I'll drink one. Like I don't have a moral. I ain't paying for it. It's too expensive, you know. And if I'm feeling like I'm getting sick or something, I'll drink a little Jack Daniels or something. Just I've never been drunk in my life, but Americans are so stupid about their alcohol consumption because I have adult friends, people who are my age, you know, who like go out to eat and they like take pictures of their alcoholic beverage and put it on Facebook. Like, look, I'm eating at this restaurant and look, I've got alcohol. Like you're 12 or something. Like you're 45 years old. Nobody cares. But the truth is though, everybody cares because Americans are obsessed with alcoholic beverages.
I think
And the
Russians are
quote-
worse.
Hang on, no, it's different. And the cool factor of drinking alcohol is this mostly American thing. When you go to Europe, everybody drinks beer. So nobody cares. You're not cool because you drink beer. So it's not a social cool factor to have a beer at the lunch table in Germany or something. So it might as well be 14 because nobody's going to do something stupid like Americans who think it's cool just to drink a beverage that has alcohol in it, irrelevant of taste or health benefits or health detriments or anything else. It's just a cool factor. It's like wearing Nikes versus Reeboks or something. I got to have a certain pair of shoes, and I got to have a certain pair of pants, and I got to have a certain purse, and I got to have alcohol in my drink when I go out to eat. And that's just American stupidity. So we have to have a drinking age because our society will abuse alcohol more so than other societies will.
When my mom and dad went to Europe, my mom was talking about some of their culture is to actually, why they do it so early, so the parents will teach them how to drink responsibly. That way
Right,
when they come
yes, that's part of what they do.
21, it's like, oh my gosh, I got this much freedom.
Right.
They don't go.
They're acting like it's such a big deal.
It's not.
Right.
It's, well, we've been doing it since 14.
So it's not a big deal.
It's not a big deal. It's just
Yeah, so you go to a party when you're 20 in Germany and you just drink a beer or two.
I didn't care.
Act like it's what you do.
It's like freedom that you never have.
Yeah.
You go
Yeah,
like
people
crazy.
are nuts.
But like when you teach your parents supervision, stuff like that, you learn how to like actually live. That's part of the culture.
That is correct. It's a cultural issue. The other part of it is that there is some evidence to show that it's probably not healthy for you when you're still in a developmental age. Brain development, things like that, you probably don't. And that's true for anybody, and that's why people should be so cautious about the drugs they allow these doctors to give their children. Okay, no soapbox I'll get on. But your brain development, okay, you got all kinds of development going on, but especially your brain development doesn't need chemicals injected into it. You can inject them into my brain. My brain's on downhill, okay? So I'm not growing, my brain's not getting any better, okay? But yours still is possibly, and therefore it really doesn't need any hindrances to that. possibly, depending on your age, genetics. But back to what we were saying, other things ethanol does. Ethanol, when you cross a certain line, okay, and it's been calculated 1,000,000,000 times over, the amount of alcohol that is. And we read that's why we have alcohol beverages are sold in the sizes that they are. Is that one drink for an adult person is not going to bother. But you get 2 in you inside of about an hour, and your body kicks into a different mode, and you're going to be some level of inebriated. Okay, now 2, you're not going to be passing out. 3, it's a little worse. 4, 5, as you start climbing the ladder of drinks in a shorter amount of time, then you're going to have serious detrimental effects, both mental and physical. It's going to damage your liver, it's going to damage your heart, does things like that. If you drink too much in too short an amount of time, it will stop your heart. That's alcohol poisoning. And there's been a lot of people who died from that. So you can die from long-term alcohol use that's normally from the liver shutting down. You literally wear your liver out. Very similar to people who become diabetic because they don't eat right all their life. Your pancreas gets worn out, so you become diabetic. Some people are born diabetic. That's totally different thing. Type 1 versus type 2. Some people are born with a bad liver, and that's just bad. They need a liver transplant when they're like teenagers and stuff. That's just nothing good about that. Some people destroy their liver by drinking too much alcohol. Some people destroy their pancreas by eating too much carbohydrates and sugar all the time. Okay, but about 2 to 3 drinks to do that. Or you can kill yourself in the short term with alcohol by drinking a lot of drinks in a short amount of time. So if you take a Jack Daniels bottle, a fifth of Jack Daniels, and just turn it up and guzzle it, it likely will kill you. If you don't throw it up. And that's the reason alcohol consumption makes people vomit, is your body's trying to get the poison out of your system before it kills you. That's your body's reaction. So anybody who is throwing up from drinking alcohol is they're in their poison. They've reached a level, and everybody's different because everybody has a different amount of blood in their bloodstream. Everybody has a different body mass, and males and females are different when it comes to consumption of alcohol. But when somebody gets to the point that they're starting to throw up, they have reached a level of poison. Their body is it's saturated to the point that their brain goes, we're about to be dead. If we don't get this out of our system, we're going to die. And you're going to start throwing up. So, just like any other poison.
Is their addiction rates a lot lower than ours?
I would imagine so. I don't know that for a fact, but I would imagine so. Because alcohol has such a weird, I don't know the word for it, it's called weird, such a weird cultural thing. It's just weird. People, and like I said, people my age still act like teenagers. I mean, it's like, I've got to be like, congratulations, You went to the gas station, you paid $3 for beer. But it's like this whole thing. But it's an American thing. So you go to Europe places. Paul, do you have a question?
Yes.
What?
What are your thoughts on like psychedelics?
It's a terrible idea. Terrible idea.
Like mushrooms?
Yeah. You will mess your mind up permanently. Anytime you do something like that, you run the risk. First off, you run the risk of harming yourself or others while you're under the influence of that or any other drug, right? But the thing about psychedelics is that you run the risk of a permanent mental condition. It will mess up the brain chemistry permanently. So more so than like marijuana, which can mess up your brain permanently by killing brain cells, right? But it doesn't, like somebody who's high on marijuana eventually comes out of their altered state, right? Sometimes when people take these psychedelic drugs, that altered state doesn't go away. Or sometimes it just comes back unannounced without taking drugs. And that's a very, very dangerous, life-altering thing. And you only have to do it one time. So you can take some of this stuff one time, and then you're basically on it for the rest of your life. At random times, you just have a mental moment.
Start tweaking.
Yeah.
Isn't there this drug that puts you like, so you can unrelated, like, in one dosage of the doctor? Is that really?
I don't think it's one dosage, but there are
It's
drugs
something
that
like
help you.
under.
Well, they have drugs that give people who are addicted that helps wean them off of stuff. If you have a problem, like you get, that's what's bad about some hard drugs like heroin and stuff like that. Like your body gets so dependent on it, you just stop taking it. You get methadone. They give that to heroin addicts. But you have to come off.
Oh.
Yeah, because some of that stuff though, people are so dependent upon that drug that you just cold turkey stop it. You have to either wean yourself off of it, which is difficult because it's a narcotic drug, or they have to give you something else. It's sort of easy. But that's a rehab situation. You gotta go lock yourself in a room. I was watching a video the other day about a guy who had to go to rehab for pain meds and stuff. They literally locked him in his room for 6 days, just checked on him every hour and made sure he wasn't dead. And that's literally what you do. All right, here we go. How do you name one of these things real fast before we get out of here? Or naming formula for an alcohol. Very similar to the previous thing, so pay attention to this. Okay. Prefixes, right? So meth means 1, F means 2, prop means 3. Okay. So methanol means 1 carbon, all single bonds, alcohol. Ethanol means 2 carbons, all single bonds, alcohol. All right. So what we do here is you take the formula for methane, which would be CH4, right? And you simply take one of the hydrogens and slide it over here and put an oxygen in there. So there's still 4 hydrogens there, right? Carbon and 4 hydrogens, and an oxygen has just been added in. Not to get a unit ahead of ourselves, but right here on the board are 2 drawings. Okay, we're going to learn to make these drawings after fall break. But this is methane, and this is methanol. Okay, so the only thing that's happened here is this hydrogen has been removed, and then an oxygen and a hydrogen added back. So the same number of hydrogens. There's still 4 hydrogens. There was 4 down here. There's still 4 here. We just inserted this oxygen. The only one I need you to memorize right here that doesn't really follow the patterns that we talked about is I want you to memorize isopropanol. That's the rubbing alcohol. Okay, it's the same formula as propanol. As we will learn after fall break, the isopropanol and propanol is just a different arrangement of the oxygen. Where is the oxygen at in the molecule? It makes a difference in propanol and isopropanol. So same formula. You just need to remember that. Okay. All right. That's it for today. Tomorrow's a quiz on ionic compounds and a discussion of acid nomenclatures. Wednesday should be a review. Thursday's a test. Friday I won't be here, and I don't know what y'all going to do. Just to say we did it. Whatever it is. Get you a crossword.
Yes.
Color.
Yes.
What we want. What we want.
Tomorrow's quiz is on a
Crossword. No, just ionic. Just ionic.
So it'll be like,
the math ones.
like nickel phosphide, stuff like that, the names of it, the equations, what the equations.